All right, so I think I'm recording. Let's take a look at these three problems. In these three problems, they give us f and g, and they ask us to consider new functions that are built with f and g and define their domain. So we don't necessarily have to find the formulas to find these domains because we have formulas for finding the domains itself. So in part A, the domain of fg will be the domain of f intersected with the domain of g. So let's find the domain of f here. And in the domain in f, we know that the domain of any function is the set of all real numbers, excluding any values that cause division by 0, and also excluding any values that would cause us to take the square root or even root of a negative number. So we have a variable in a denominator, and we have this expression 4x minus 12, and we're curious if there's any value of x that would cause this to equal 0. So we temporarily set it equal to 0. We solve the equation, and we say if x were allowed to equal 3, then this denominator would be 0, and we don't want that to happen. So the domain of f is all real numbers, excluding positive 3. And let's do the same thing for function g. And again, you begin the same way each and every time. The domain is the set of all real numbers, excluding any values that cause division by 0, and excluding any values that would cause you to take the square root or the square root of a negative number or the even root of a negative number. So here we have both going on at the same time. We've got a radical in the denominator, and so we need this 12 minus 2x to not equal 0, and at the same time, we need 12 minus 2x to be greater than or equal to 0 to take the square root. Excuse me. For those to both, I can work with one inequality. For these to happen at the same time means this 12 minus 2x has to be strictly greater than 0. All right, so let's solve this inequality. Let's add 2x to each side. Divide by positive 2. And that we get that x is less than 6, which makes sense. If you plug in values that are bigger than 6, then this is going to be taking too much away from 12, and it's going to be a negative value. So the domain for g is from negative infinity up to 6, but excluding 6. So we're going to use these two domains to help us in part A define the domain of this new function f times g. So let's make a picture. With enough practice, eventually you'll be able to do it maybe without drawing the pictures, but I think the pictures help. So we've got 3 and 6 that are points of interest. And up here we're excluding the number 3. And it's a set of all real numbers except that 3. So here's a picture of that set, the domain of f. And we want all values that are strictly less than 6. So here's that picture. So the domain of this new function fg, and I don't even have an expression for it, nor do I need one unless they ask for it. You have to be in both sets to be in the intersection. So that's where that idea and comes from. 3 is not in both sets. 3 will not be in my intersection. 6 is not in both sets. It will not be in the intersection. But to the left of 3 is in the top set and it's in the bottom set. Therefore, to the left of 3 will be in the intersection. Numbers that are between 3 and 6 are in both of these sets. Therefore, they'll be in the intersection. To the right of 6 is not in the second set. It will not be in the intersection. So our final answer for part A is the domain is a set of real numbers from negative infinity up to positive 3, excluding positive 3, and then from 3 up to positive 6, excluding 6. So there's our final answer for part A. Let's move this aside because we know that in part B, we intersect F and G, which we have that answer right here. So we could just use this set and intersect it with the set that avoids division by 0, but for some reason I always just, I could use this result, I guess, that I just usually moved aside and revert back to my domain of F and domain of G. All right, so in B we need the added restriction that G of X cannot be 0. So we temporarily let it equal 0 in order to know what to avoid. G of X is this ratio 3x over the square root of 12 minus 2x. So if a fraction reduces to 0, it's not because the denominator can never be 0. It's because the numerator might be 0, and in this case, if x is equal to 0, the numerator is 0, and this fraction reduces to 0. So what this tells us is that g evaluated at 0 is 0. So in order to avoid g of x from being 0, we must avoid x from being 0. So over here, if we sketch that, the entire set that avoids g of x equals 0 is the set of all real numbers excluding 0, and 0 is to the left of 3. So I'm going to go ahead and put in 3 and 6 on this number line. And it's all real numbers excluding the value that caused division by 0. So to be in this, for the domain of F over G, we have to intersect these three sets. And it's probably easiest to do that for right now in the form of a picture to see, well, 0 is not in all three sets, so 0 can't be in the intersection. 3 is not in all three sets, it cannot be in the intersection, and the same for 6. 6 is not in all three sets, so it cannot be in the intersection. But to the left of 0 is in all three sets, so to the left of 0, values of x that are strictly less than 0 are in the top set and the middle set and that final set. So they're in our intersection. And values between 0 and 3, because somewhere here to the left of 3 is 0, and in between 0 and 3, those are all shaded in all three sets, so they're in our intersection. And between 3 and 6 is in all three. To the right of 6 is not in the middle one, so it's not in the intersection. So here's a picture of the domain for this part B. And if we describe that, it's from negative infinity up to 0, excluding 0. And then from 0 to 3, excluding 3, all the way up to 6, but excluding 6. So there's our answer for part B. If we look at it, it's almost the same as our answer in part A was, It's just that we have the added restriction that we had to throw out 0. That if you look at a picture of the solution set, or of the domain sets, I should say. You can see how they look real similar, but the one here on the bottom, the one on the top, excludes only 2 values, 3 and 6. Those are also excluded here in the bottom with the additional restriction that we excluded 0 because it was 0 that caused division by 0. And that's why we had to throw it out. So in part C, we have this idea is very similar. It continues. We intersect the domain of F with the domain of G, but this time we're concerned, is it possible that F of X, is there any value of X that would ever cause F evaluated at X to be 0? Well, let's temporarily, we actually want to avoid this, but we temporarily let it happen so we know that what value of X is causing this to be true. So whenever you have a fraction that reduces to 0, it's definitely not because the denominator can never be 0, it'd be undefined. It's because of the numerator if it does equal to reduce to 0. And here, if X were allowed to equal -8, F evaluated at -8 is equal to 0. We don't want that to happen, so therefore we have to throw out -8 from this set. So here my picture is getting smaller and smaller over there. I hope you can see it. The domain of F was all real numbers excluding 3. The domain of G was all real numbers that were strictly less than 6. And now I want all real numbers that exclude -8. So, oops. This is all the values of X that will result in an output that's not 0. So when we find the intersection of these 3 sets, that'll be our answer for the domain of G over F. And -8 is clearly not in this set, so it's not in the intersection. It's not in all 3 sets. So we're going to throw out -8 from the domain. And +3 for the same reason. +3 is not in all 3 sets. Therefore, +3 is not in our intersection. And 6 is not in all 3 sets, so it's not in the intersection. To the left of -8 is in all 3, so it's in our intersection. And between -8, and if we make this a -8, between -8 and +3 is in all 3 number lines. It's in the shaded region, so therefore it's in the intersection. And between 3 and 6 is shaded in all 3 sets, so it's shaded in the intersection. Greater than 6 is not shaded in the second one, so therefore it's not in the intersection. You have to be in all 3 sets to be in the intersection. So the domain of G over F excludes 3 and 6 just like part A did, but in addition to that, it excludes -8. So we've got from -infinity to -8, from -8 to +3, and from 3 to 6. All right, so there's our final answer, and you can see in this picture, like I said, that it's almost the answer that we had in A, but it had additional restrictions that prevented it. Threw out 3 just like our domain of FG did, and it threw out 6, but it also threw out -8 because it was -8 that caused division by 0. So here's the domain of the 3 answers that they wanted, and I hope that helps, and I'll talk to you later. Bye.